Hello and welcome to this tutorial on thrusters. I'm going to be looking at how we can use thrusters, which are a construct that you can code in order to move stuff around in your game. So the way we're going to look at it is we're going to start with a bit of a hot air balloon, which seems like an appropriate thing to use on with thrusters. And we're going to look at how we can take control of a hot air balloon instead of the normal player character, and how we can fly it around our game world. So this is a little bit of a deep dive into thrusters and how we might go about using them. There'll also be a quick guide on thrusters as well. So if you just want to know the bare minimum that you need to know in order to get thrusters working and then take it from there, then that's going to be a really good opportunity for you to do that. If you want to go fully into what's going on and make something in like a step-by-step follow guide, that's what this one's all about. We're going to do some programming, so you're going to need to use the advanced mode in Crayta. And I'm starting from an empty template, but you could equally start with your game world that's already been made. Doesn't really matter too much, but let's get going. So to start with, we need to create a template for the hot air balloon that we're going to make. So to do that, I'm going to go to the meshes section of the library and look for the hot air balloon. Just going to place that in my game world, and then I'm going to create a template from that by over here on the entity editor, clicking template, create new template, and this is my hot air balloon template. Okay. Now that that's been made, I can delete it from the game world because we're going to generate that using code. So the way we're going to do that, well, first let's just check that it's a template in. Yeah, there it is. There's our template. Okay, so let's generate it on the player. Now, we don't necessarily know where the player is going to be, but the best way to do this is to look at the player template. Now, there's going to be some stuff in this tutorial where I do it the way that I think is a good way to do it, but there are many, many different ways to solve this problem and to make this happen. My way is a way. There are many, many other effective ways. Some might be better for different scenarios. Some might be useful. Some might be cleaner code. Some might be less clean code. You know, there's lots of different ways you can solve this problem, but this is a way, and it's worth just going through the motions of like, okay, so this is what a thruster is, and this is how it works, and this is one way we can use it. So I'm editing my player template, and I'm going to add a script folder to this. So entity create child script folder. This is going to be called player hot air balloon. And then within that script folder, I'm going to create a script called hot air balloon controller. This script is going to be only concerned with generating and controlling the hot air balloon that I want the player to be in control of. So I'm going to open it to edit that. And on the init function is where we're going to create the hot air balloon. But firstly, we need a reference to the template of the hot air balloon that I created. So let's create that in this property bag. Name equals hot air balloon template. Ballon template. Air balloon template. The type is a template. Okay. By saving that, you'll see that it appears in the entity editor over here. And then you can use this drop down to select the template you need. If you've got loads of templates, it might just drag and drop that in over there. So now we have a reference to that. Let's create it. Now creating a new instance of a template is pretty straightforward. On the init function, we're going to do get world, get a reference to the world. And then move this up a sec. Get world, and then spawn. So it's expecting the world to spawn, and it needs a template, which is that property that we created, hot air balloon template. It needs a position. So I need to get hold of the player's position when they are first spawned. This is because I might move that player position around. I don't want it to be hard coded into this hot air balloon script. I want to be able to use the start location locator that I've got in my game world to set my player position. So I need to get a local reference to that to the player position, because I might also use it more than once or for different things. So let's just get hold of that position, a local variable. So local start position equals self get entity. So get hold of the character that the player is controlling, and then get the position of that thing. Okay, so that will then store the position in there, and now I can use that in there when I spawn the hot air balloon. So spawn a hot air balloon at this position, and it's asking for rotation as well, but we'll set that to 0. We don't really need to worry about that for this situation. Okay, so if I press F5 and run that, we should see that the template has indeed spawned. There's an instance of that template that's been spawned in my game world, and it is right on where my player is. Now, the camera is a bit difficult to see what's going on, and I can't move because I'm stuck, but I can jump, sort of. So I am going to make it so that the player is only controlling the hot air balloon, and this is just to make it really clear and simple for the player to be able to know what they're controlling, essentially. You could make your game a little bit more complicated if you want to, but I like to keep it a low barrier, low entry barrier to players who have never played this game before. So I'm going to make it super straightforward. So I'm going to go to my player template, and I'm actually just going to turn off, make them invisible. I'm going to make their speed 0 so they can't move. I'm going to turn off jump so they literally disappear from existence. It's just the balloon that we're focusing on here. Maybe some collision stuff might be important. Like, I don't want the camera to collide. The player, I don't want them to collide with anything either. I'm going to change the camera actually to orbit. I don't really like the idea that looking around will turn the hot air balloon, because it's a physical object. I want the hot air balloon to just be there, and we're affecting it using different things. So let's just make it an orbit camera mode. Make the camera 1,000 units away from the hot air balloon. There we go. So we've spawned a hot air balloon. I need to turn that crosshair off. That's a lot easier to see what's going on though. Let's turn the crosshair off. That's in the user, not the player. Show default crosshair. Let's uncheck that. Okay, so we've spawned in our hot air balloon. Now let's start making it a thing that we can play with. Right. So let's go to the template and turn on physics. Now, when I turn on physics, its calculated mass is 5 metric tons. So that's because it's big. The calculated mass is based on the size of it, right? So let's override the mass and set it to 1 kilogram. Yeah, I mean, still got weight. It's still got mass. So yeah, I think that's right. Let's leave it at 1 kilo. Let's not collide with the player. Okay, let's see what happens when I dive. Okay, so it falls to the floor. Now, one thing you might notice is that the camera isn't really following it. If I move this start location up, the player is falling, and the hot air balloon is not. So, and that's because the player is falling through the world and the hot air balloon is not. So let's join up the player and the hot air balloon. Let's make them at the same position. So the way I'm going to do that is I'm going to attach the player to the spawned hot air balloon. So we can do self get entity. Back to this hot air balloon controller script. Remember, this script is attached to the player. So when I do self get entity, that's getting hold of the player character. And we can do the attach to, use the attach to method, and then attach it to another entity. The entity we want to attach it to is this one, which is the instance of our hot air balloon template. So let's store that. Let's actually store that in a persistent variable, self.balloon. So this means that from now on, after this init function has been executed, anywhere else I use self.balloon in the script will refer to the hot air balloon itself, and get entity refers to the player. So self.balloon is that. So that's that instance of the hot air balloon is generated, then stored in their self.balloon. And now we need to attach the player. So self get entity gets the player, attach it to the balloon. Save that and run that. Still not quite right. That could just be the positioning now. Let's 0, 0, 0. Okay, yeah, I think that's okay. Let's open up my scripts. I've got a reference. Yeah, so we sort of now have a hot air balloon that's sort of falling to the floor. I've noticed in my script here that I just changed the position slightly. So I changed the Z, which is up and down. I add 300 to that, just so it's a bit higher up. There we go. Yeah, that looks a lot nicer. So I'm just adding 300 to that Z so that it falls in from the start. So we can see physics is working. We can see that the camera is looking at the hot air balloon, because the camera will always look at the player character, even if they're invisible. Or by default, that's what the camera does. So rather than playing with the cameras, I've just attached the player to the hot air balloon. Now's the time to set up our thruster. So a thruster is essentially a physics concept. The idea is that a thruster is a thing that's attached to an entity in your game, and it can thrust it in the direction that you tell it to. So you set the force of the thruster, and you set the force as a vector, and it will thrust the object it's attached to in that direction. The cool thing about thrusters is you can combine them. You can have multiple thrusters on one thing. You can, put a thruster on something and then turn it on and off and all that sort of stuff. It makes kind of directing stuff around your game world in the physics engine quite straightforward. And so we'll see how we use that now. So let's attach it. Let's create it with the balloon. So it needs to be created on an entity. And so you reference the entity first. So self.balloon is the entity I want to create the thruster on. And then the method notation is create thruster. That's it. Another thing we need to do, though, is we need to store that. Let's store the thruster in a similar way to the way we stored this script variable here, where we stored the balloon. Let's store it in self. And if I do, after I've created it, I can do self.thruster set force and give it a vector with the force that I want to apply. So remember, a vector is a direction. It's in 3 dimensions. It uses like a coordinate system to tell which direction. So if we go into the game quickly and I click on the start location, the red arrow is X in my game world. The green arrow is Y in the game world. And the blue arrow is Z in my game world. So X is left to right, Y is front, forwards and backwards, and Z is up and down. So if I want my hot air balloon to go up, I just need to apply a positive number on the Z axis, which is this blue one that goes up. So let's keep X and Y 0. And I'm using this tooltip here to tell me what number I'm talking about. It says where Z is generally up, so that's good to know that that's the Z. So 0, 0 for X and Y, and let's apply a force of 1500 to Z. Okay. And that's going to just do that from the beginning. The thruster will continually apply that force. So that's another cool thing about the thruster that's a little bit different from things like add impulse and add force and stuff like that. The thruster will continuously apply that force to the object that it's attached. So the thruster is continuously applying 1500 to the hot air balloon. So it's always going up. Go. So that's the basics of thrusters. Now, the next few steps or the rest of this tutorial is going to be really about how we can manipulate that thruster so that it feels like we're in control of this hot air balloon. We're going to add some wind, we're going to add some drag, we're going to add like a maximum velocity and stuff like that to it. But if you're just here to look at how do I create a thruster, there you go. Okay, so we've created a thruster, we've applied a force. Now I don't actually want that force to be applied there. I want the player to apply that force. So the way we're going to do this is we need to get hold of whether the player is pressing jump or not. If they're pressing jump, I'm going to apply the force. If they're not pressing jump, I want the balloon to gradually fall back down to ground. So I'm breaking down the problem as I speak. So to determine whether the player is pressing a button or not, let's just start with if they've pressed the button, set the force. Yeah, on button pressed, button name, end. Okay, so if they've pressed the button, let's check what button they've pressed. I want them to press jump. So if button name is equal to jump, then if they've pressed jump, then self.thruster set force vector.new 0, 0, 1500. And on button released, button name, let's just copy this and set that to 750. So it won't plummet back down. There's still some upward momentum that we're keeping going. And I might actually set that as default at the beginning. So F5, so gradually falling down. If I press space, then I'm applying an upwards force using my thruster. And when I let go of space, it gradually falls back down. Still applying like a lesser force. It's the force that I'm applying when it falls back down is not enough to hold it up, but it's enough to make it feel floaty. Remember, this is a hot air balloon. It's not. So it needs to feel floaty and light. I mean, we could even up that a little bit so it falls like faster or slower. But I'm going to leave it at that because I want that to be how my balloon feels. So that's an easy way now of approaching thrusters, and that works. But we can do more. We can do more than that, because what we can do is we can combine it with some other forces going on to create what feels like a hot air balloon in the wind. So at the moment we've only been playing with the Z-axis up and down, but let's have a look at how we might control it using the camera. So when you look around the hot air balloon, so whatever direction you're facing, the wind blows that way. That's what I want to do next. So that's how do we approach that? Let's have a look. Well, we're going to need to do this in the onTick function. OnTick function is by the Crayta game engine every frame of the game. And so we can get hold of the direction we're facing every frame and then apply the force every frame in that direction, or change the force accordingly. So it updates every frame. So let's look at doing that. Hot air balloon controller onTick gets called every frame, and then delta time is what's given to us. So that's the amount of time since the last time onTick was called. Delta time. Okay, so we need to get hold of, now we need to look at how do we get hold of the direction? So wind direction. I'm going to start writing some comments because this code is getting longer and longer. Let's comment these things. Create hot air balloon. There, that's hot air balloon creation code. Create thruster code. Yeah, wind direction. So get the way we're facing. That's going to be to cam position. So the position of camera and get what we're looking at equals self get entity get user. So the user has this function get camera look at, and that gives us two values: the position of the camera and a point the camera is facing. So from those 2 points in my game world, I can figure out what direction that is. So we've got camera position and look at. Camera position will hold the camera, look at will hold the position we're looking at. So let's create a directional vector for that. So call it facing equals look at minus camera position. It's that simple. We just minus one from the other to get the direction. Sometimes it's also a good idea to normalize that, but let's just remove the Z. We don't care about Z. Z is controlled by the thruster, the burner that goes up and down. We want to know which X and Y we're facing in. So this is going to be vector.new facing.x facing.y. Z is 0. And we're just going to normalize that. Yeah. So when you normalize it, all it means is that everything then is a number between 0 and 1. So it removes any kind of length from our vector. So at this point here, the vector we're getting, or the vectors we're getting, when you minus one from the other, you're actually also getting the magnitude, like the distance as well as the direction from each other. And we just want the direction because we're flying, and doesn't matter where we're looking because it could be the sky. And so we just want the direction. So now we have the direction, we should be able to use that. Let's create a speed. Let's just self.thruster. Just set the force in that direction. Direction.x times. We're gonna need something to scale that. So a speed, wind speed. Set it to 2. Speed. Direction x times direction y. Wind speed. Actually, not 100, 500, something like that. X, Y. How are we going to do the thrust? So at the moment, we're setting the thruster up and up force in these button presses here. But now that we're adjusting our thruster in the on tick method, if I was to set 0 here, or even 1500, that wouldn't reflect what these buttons were doing. So that would then break this code here. So what we need to do is essentially create a Boolean that we turn on here, off here. And that will give us the state of whether the player is pressing jump or not. Then we'll check if they're pressing jump in our on tick method. If they are pressing jump, then we will apply a force of 50. And if they're not pressing jump, we'll apply a force of 750. See, that makes sense. This is going to be done in our burner logic here. So create a property self.burner on equals false to start with. And when they press jump, self.burner on true. And when they release jump, self.burner on it's false. Now, in our on tick method, if self.burner on, then let's create a upwards force. Let's call it burner force. Burner force equals 1500. Let's set it to 750 here because we've got to create a variable anyway. So the memory is being made anyway. So let's put something in it. 750 in it, which is that number there. And only if the burner is, they're holding space down, then up that to 1500. Cool. And then all we need to do, instead of hard coding this here, we just put burner force there. So now we're creating our thruster. We're setting the force to the direction that we're facing in terms of X and Y multiplied by the wind speed, which is 500. And then we're applying on the z-axis, the up and down axis, we're applying this burner force, which will either be 750 if they're not holding space, or jump, 1500 if they are holding jump. Let's see whether that works. So I'm just in the camera around to see if it's doing. The hot air balloon. It's hard to tell. Error. Here we go. Error. Set force. Stack index 2. Receive expected user data. Receive number. I tell you what that is. That's because this is expecting a vector, and I've given it 3 numbers. So vector.new. Go. That needs to be in a vector. Okay. Whoa. Okay. So we're definitely applying a force in X and Y. but I feel like there's something not quite right with the hot air balloon. So a couple of things. That wind speed that we're applying, way too much. Reduce that a bit. So I'm just feathering the burner. Yeah, there. So it is applying the force, a force in the direction that we're facing. So I now have control, except the wind is really strong. In fact, I feel like the wind should really be something that we choose whether to have it on or off. That might be fun. I mean, it's quite fun like this, quite chaotic like this. And if a chaotic game is what you're after, then this is a good opportunity for that. Because you can't really, it's quite difficult to control it, but it is controllable. To make it even more controllable, or even tighter controls, we can wrap this wind stuff. We can wrap that in a conditional and check whether we're pressing mouse essentially or not. And if we're pressing the mouse, then shoot us in that direction, and if we're not, then don't. So sorry, not the mouse, the primary fire button if you're on controller. So if button name is primary, then so we're basically doing the same sort of thing we did with the jump burner, except we're doing it with the primary button and the wind. Self dot false. Self dot on is there. Reset it to false at this point. Okay, and the wind direction. They just do it. What's interesting that there's no drag, so it's gonna just continue at the same speed. So we're gonna have to look at that anyway. Let's set wind speed to 0, just like we did with the burner here. If self.wind on, then wind speed is 300. So similar to the way we did this, we're doing this. We're still getting hold of the direction that we're facing. That probably only needs to happen. That would be good to put in this. But we need the wind speed. I like this one line here. Set everything. So I'm going to just leave that. You might want to tidy it in a different way or optimize it in a different way. Because essentially these 3 functions or these 3 lines of code here will now run even if they're not being used, which isn't optimal. It's not ideal, but it keeps it very clean because we've got one place we're updating the thruster. So here we are in a situation where you can choose how to proceed. If your game isn't very logically intense or CPU intensive, then you could leave this in for the sake of cleanliness. If your game needs as much grunt as possible, which most games do, let's face it, then you probably want to put that in your conditional statement and then have a, okay, all right, let's do that way. Fine. Local wind force X is 0. Wind force Y is 0. And that stuff in here, that including wind, that anymore. Then got these variables, and then we just make wind force X direction dot X times wind speed, wind force Y direction dot Y times wind speed. That, and here wind force X force Y. Okay, more optimal, fine. So now this code only runs when we're holding the mouse or when we're holding primary fire down, which is, yeah, better. Let's face it. So let's see if it all works still. So the burner still works, going up. And now when I press the primary fire button, it moves me in a direction. Hey, cool. One thing though, the drag looking, when I press it and then let go, continue to go in that direction. Yeah, that might get frustrating as a player when you're trying to be more accurate with your flying. So I think the player might want it to slow down faster than that. Otherwise, they're going to have to continuously move around the balloon, which might be another game mechanic. Continuously move around the balloon, applying wind in different directions. That might be a better option if make a UI sort of system to do that. I think I'm going to just have drag on my balloon so that it slows down. Now, that's not at all physically reliable knowledge. That's probably not what happens at all with balloons, but it might make it feel like, might make it feel right. So let's do that. Let's create a drag section. And this is really going to be if not wind on. Then. So if we are not currently blowing the wind, then we want to slow down. We could write an else for this if we wanted to, but again, just going to keep it separate for now. Drag. So let's create. So wind force X equals wind force X plus. Okay, so from this, we really need the velocity we're going, and then we essentially want to fire a force in the opposite direction that we're traveling using our thruster. Depending on how quickly we're traveling, the faster we're traveling in one direction, the more force we should apply opposite direction. So we need to get our velocity and then apply the opposite velocity in our thruster. So let's get hold of our velocity. Local velocity equals self.balloon get the velocity of the balloon. Set the Z of, because our drag, I'm not going to make our drag and have any effect on Z. I don't want it. So yeah, okay, cool. Get the velocity. Then vel.x. I'm going to times equals vel.x. I'm going to times that by minus 0.3. Now I know that 0.3 is a good value, so it will a third of our velocity will apply in the force. Now the only reason I know that is because I've already played around with this, but this took some trial and error to figure out a good number to apply in the opposite direction. Vel.y equals vel.y times minus 0.3. So essentially we're figuring out how fast we're traveling in a direction, and then we are applying a force in the opposite direction on the XY plane. Yes. So we need to add that to wind force x. Equals wind force x plus L.x. Yeah. And the same for wind force y. Okay. So we've got our drag. We are working out how fast we're traveling in the two-dimensional direction in 2 dimensions. We're not worrying about up and down. Up and down's taken care of with this burner, and yeah, that's all good, already sorted. So we're just working out how fast we're traveling in, on a flat plane, and then we are applying the opposite force to that if we aren't currently blowing in a direction. We're currently not using the wind to blow ourselves in a direction. We're applying an opposite force to that, and then we're adding it to our wind force x and y that we already created here. And the reason we're adding it is gradually, as this velocity goes down, so as we slow down, this number will be less and less and less until it's 0, or as close to 0 as possible. Wind force x and y are only applied, there's 0. So they're only on when the wind is on, and the drag is only on when the wind is off. So essentially, I don't need these. What I figured out from talking about it is that is actually the correct fact. Take out more code. Okay. That is the correct velocity. We don't even need that. Wind force x or y is now drag. The wind force x and y here is when we're blowing in a direction, and wind force x and y here is the drag that will slow us down. Let's see whether that works. So thrust is still working, which is good. If I blow the wind in that direction, we can see I'm moving. If I let go of primary fire, we are slowing down and stopped completely. Yeah. As close to stopping as necessary. Go in this direction. Kind of hard to see. Let's just make it easier to see. Let's set the time to 4:30 in the morning. Day length 10 minutes long. Okay. A beautiful sunrise. So going into the sky and direction. Cool. So I now have a hot air balloon that I can move around game world. And that's the cornerstone of essentially a game mechanic. So now that I've got that, with some effects and turning the effects on and off, and some sound and turning the sound on and off, I'll show you the balloons game that I sort of am halfway through making with the hot air balloon. The logic is almost identical, except that was way cleaner than the way I've coded it before. But essentially, once you've got like a few effects and some music and a bit of a setting, kind of got some chimes when the wind blows, and I've got my little burner going there. And it's you can make it quite a nice relaxing game about cafe hopping through the sky, which is something I wish I could do. Yeah, that's basically it. That's the crux of the thrusters. Hopefully this has been a fun and interesting tutorial. Hopefully you didn't get too lost when I was looking at all the physicsy stuff. It might be worth going back through it if you got a bit lost or a bit stuck. Just break it down for yourself a little bit, or even better, get in touch with people on the Discord. You can at me if you like. You can at some of the other players. If you get stuck with that physicsy coding, everyone loves to help each other out and make cool things. Yeah, I really look forward to seeing what you do with thrusters in Crayta, because with thrusters you can move stuff around, you can create vehicles, you can shoot things, who knows. Lots of stuff you can do with thrusters in Crayta. Yeah, let me know what you think of the tutorial. Any feedback is always welcome, and I look forward to seeing you in Crayta.